in 2 to 4 decoder, we will be having 2 inputs and 4 outputs. So x and y will be the inputs and D0, D1, D2, D3 will be the outputs. So we will be giving an array equal to the decoder. So within the operation of the 2 to 4 decoder, hence the x will be the input and D0, D1, D2, D3 will be the output. See, when the array is equal to 0, the circuit does not consider about the select lines. Sorry, the inputs. The output will be 0. When array is 1 and when x is equal to 0 and y is equal to 0, we get the output is D0. Right? When x is equal to 0, x is 0 and y is 0, we get the output is D0. Then when x is 0 and y is 1, we get it D2. Similarly, when x is 1 and y is 0, we get the output is D2. Then when x is 1 and y is 1, we get the output is D3. This is the operation of the 2 to 4 decoder. Right? So it converts the binary bits into 2 to unique outputs. So each output has different codes. So this is the process of the decoder. Then we write the equation for D0. So D0 x bar y bar into D. Right? Then for D1, D1 is 1 when x is equal to 0, y is equal to 1 and e is equal to 1. So we write x bar, y and d. So similarly I have to write for D2 and D3. Now we will draw the logic diagram for the 2 to 4 decoder, right? So 2 inputs and enable signal. Right? So for first D0 we have x bar, y bar, e. So we are connecting x bar, y bar and e. We get the D0. Then for D1 x bar, y into e. We will be getting D1, right? Then D2 x y bar into e. So x y bar into e. We will be getting out for D2. Then what? D3 x y e. So x y and e. So this is the logic diagram for a 2 to 4 decoder. So the operation is the output D0 will be 1 when x is 0 and y is 0 and when the enable signal is also 1. So this is the operation of the 2 to 4 decoder. Write it down. D0 will be 1, then x is 0, y is 0 and z is 0. So we can write it as x bar, y bar, z bar into E. Right? So same as like previous one, we are writing the output equation for this decoder. Then using this D0 to D7, we have to draw the logic diagram. Try this. So draw the logic diagram for inverse decoder. So you will be having 3 inputs, enable signal and 8 outputs. Draw it. Completed. Completed this side. See, listen. Remaining values put 0. Right? So listen carefully. Remaining values have put 0. So draw the logic diagram on inverse decoder. X, Y bar set in E and D6 X, Y, Z bar in E and D7 X, Y logic diagram. So you have to explain the types, representation, block diagram, truth table and its operation. Then you have to write the output equation. Then you have to draw the logic diagram. Then put the heading as encoder. The next one will be the encoder. Decoder is also another type of the combination circuit. So it performs the reverse operation of the decoder, right? Then it converts the input to in output. Then it converts the information to the coded bits. So you can give information in the input bits, convert that information into the coded bits. Then decoder will be used in the receiver side, the communication purpose. Encoder will be used in the transmitter side. So encoder is also classified into two types: 4x2 encoder and 8x3 encoder. Then first will be the 4x2. Here we have 4 inputs and 2 outputs. So the 4 inputs will be D0, D1, D2, D3 and 2 outputs will be X or Y. So this is the reverse operation of the decoder. Decoder will be having 2 inputs and 4 outputs, right? So this is just the reverse operation of decoder. Then this is the truth table. So this is when D0 is 0, D1 is 0, D2 is 0. Sorry, when D1 is 1 and D1 0, D2 0, D2 0, we be getting X as 0 and Y as 0. Right? So similarly, when D1 is 1. So when you are giving input in D1, you are getting X as 0 and Y as 1. Then when you are giving D2 as 1, you are getting X as 1. Then when you are giving D3 as 1, you are getting X as 1 and Y as 1. So this is the operation of 4x2 encoder. So listen. Normally in encoder, at the time only one input will be given. So at the time only one input will be given, right? So if you are giving more than one input at the same time, this is called as priority encoder. So this is in the next topic. So normally in an encoder, at the time you are giving only one input. Then you can write the output equation as X will be written as. See, listen here. You have to draw the K map for X and Y, right? You have to draw the K map for X and Y. Then from that K map, you get the output as X equal to D2 plus D3, Y equal to D1 plus D3, right? So you have to draw the K map for this table, and you have to put the ones and then getting this values. Any doubts? See, you have to draw the K map for D0, D1, D2, D3, right? Then you have to draw the values to the grouping. Then you are getting X and Y value. So process we will construct in the logic diagram. Listen. So the 4 inputs be D0, D1, D2, D3, right? So what is X? D2 plus D3. So D2 and D3. We get in the next value. So what is Y? D1 plus D3. So D0 is left. D0 is 0. So this is the logic diagram for 4x2 encoder. So similarly, for 8x2 encoder we are having 8 inputs and 3 outputs. Just the reverse operation of a quick of H decoder. So we are having 8 inputs, right? So we have inputs from D0 to D7. Then we are having 3 outputs. So the outputs will be X, Y and Z. You have to draw the construct a truth table. Then after the have to draw the K map and then you have to find the expression, then you have to construct the logic diagram. So the next one is 8 plus 8 decoder. How many outputs for the 8 plus 3 encoder? 3 outputs. The outputs will be X, Y and Z. Then consider two tables.